4 centuries, historical records have depicted the growth of cities, the construction of grand cathedrals, and the industrial advances of the 18th and 19th centuries as incremental responses to population pressures and evolving civic needs. Engineers, architects, and planners are said to have designed structures in proportion to the communities they served, responding to immediate demand rather than speculative foresight. City grids expanded as populations grew, monumental buildings arose as cultural, religious, or political requirements dictated, and transportation networks, roads, bridges, and railways were mapped to link populated centers. On paper, this sequence seems straightforward, even inevitable. Yet, when examining the documented dimensions and capacities of some of these 19th-century structures, a stark numerical tension appears. Entire exhibition halls were built to host tens of thousands of visitors, sometimes 3 or 4 times the local population at the time. Bridges and train stations were constructed with load capacities far exceeding the traffic they would ever experience for decades. Even utilitarian buildings, such as armories and warehouses, display floor plans and storage capacities suggesting planning for scales that contemporaneous records claim simply did not exist. These mismatches are not small oversights. They are systematic, recurring, and observable in multiple locations across continents. Consider the exhibition palaces constructed in major European capitals during the mid-1800s. Official records cite populations in the low hundreds of thousands. Yet these palaces spanned multiple acres, with interior volumes capable of accommodating tens of thousands simultaneously, each hall elaborately detailed with ornamental masonry and engineered support systems meant for weight far beyond typical human occupancy. A visitor walking through surviving illustrations or preserved structures encounters an almost dizzying dissonance. The building's capacity suggests either a population far larger than recorded or events of enormous scale that never seem to appear in contemporary accounts. This video explores historical interpretations and unanswered questions found in existing records. It does not present definitive conclusions. Within this framework, one observes that these scale anomalies are not isolated phenomena. They repeat across geographies and functions, universally large domes in religious or civic architecture, unusually wide boulevards with supporting infrastructure capable of carrying more traffic than historical population numbers justify, and storage facilities dimensioned for volumes not consistent with the known commercial activity of the period. Across dozens of examples, the mismatch is palpable. The designs presuppose scenarios that the records do not corroborate. Railway stations provide a compelling illustration. Early stations in both Britain and the United States, built during the first half of the 19th century, often featured multi-story platforms, extensive waiting rooms, and vast ticketing halls. Historical passenger records indicate daily throughput in the hundreds or low thousands, yet the structures were sized for tens of thousands of passengers. Structural engineering within these stations reflects foresight for weight distribution and crowd management well beyond the documented usage patterns. The mathematical and material sophistication embedded in these buildings implies preparation for something larger, something intensive, yet the historical record remains silent on any such high-volume need. Warehouses and industrial facilities further deepen the curiosity. Many storage complexes, particularly in port cities, feature high ceilings, vast open floor areas, and architectural reinforcements capable of supporting immense loads. Shipping records suggest modest trade volumes during the period of construction, yet the facilities clearly anticipate continuous throughput far exceeding what was economically necessary. Even in rural areas, industrial buildings exhibit this characteristic: oversized foundations, multiple auxiliary structures, and mechanical systems ready for operations on a scale never realized. The repetition across regions and building types indicates an architectural philosophy attuned not to contemporary necessity but to projected scenarios, or perhaps prepared for events that never transpired. Public spaces, too, reveal this pattern. Squares and parks in urban planning documents from the 18th and 19th centuries are sometimes designed to accommodate far larger assemblies than the cities could sustain. Wide avenues intersecting at monumental nodes, fountains, and promenades arranged for tens of thousands of people, yet census data suggest populations only a fraction of these potential capacities. Even when accounting for future growth, which planners often cited as justification, the scale of some constructions appears disproportionate, inviting closer scrutiny of the intentions behind such ambitious urban layouts. The engineering precision further reinforces this observation. Structural calculations, preserved blueprints, and surviving buildings demonstrate attention to load-bearing, materials optimization, and spatial efficiency. These are not the haphazard constructions of speculation, they are systematically over-prepared. Iron frameworks, reinforced arches, and carefully modeled stress distributions indicate that architects and engineers were working with exact specifications and contingencies that went far beyond known population or economic data. This level of preparation challenges intuitive assumptions about the relationship between necessity and design. Beyond Europe, similar phenomena are present in North America. Large civic buildings constructed in mid-19th century U.S. cities, including Capitol buildings, courthouses, and exhibition halls, mirror the European examples in scale and sophistication. Archival photographs and floor plans reveal multi-story interiors, massive domes, and expansive corridors, all intended for capacities surpassing contemporary urban populations. Even frontier towns, with relatively modest populations, feature brick and stone structures of surprising scale, often with decorative elements more suited to a metropolis than a nascent settlement. The repetition of these features across continents, across cultures, and across differing administrative systems highlights the anomaly. Architectural scale appears uncoupled from immediate demand. Bridges, too, offer illustrative examples. Suspension bridges, railway viaducts, and stone arches from the same period often incorporate redundant supports, multiple layers of structural reinforcement, and width allocations capable of accommodating traffic far exceeding historical estimates. Contemporary engineering commentary praises the foresight and elegance of these constructions, yet it rarely addresses the mismatch between capacity and documented usage. In some cases, bridges are wider than modern traffic projections would have required, with piers and abutments designed to endure stresses far beyond contemporary loads. Such systematic over-engineering raises questions not about functionality but about intent, planning, and anticipation. Even functional ornamentation contributes to the overall discomfort. Domes, spires, and colonnades are not merely decorative, they serve structural purposes. The integration of aesthetics and engineering demonstrates an understanding of complex forces and material behavior. Architects were calculating stresses and load distribution as if preparing for maximum occupancy, or even scenarios that would demand rapid adaptation of the spaces. In many cases, this sophistication predates widespread industrial or population growth by decades, creating a temporal mismatch, structures designed for an intensity of use that history indicates never occurred. Everywhere one looks, the evidence compounds: oversized halls, extended corridors, reinforced structures, expansive public squares, and fortified industrial spaces. Historical records provide no clear explanation for why this preparation exists, yet the technical details, material investment, and construction timelines consistently support these unusually large scales. The mismatch is consistent across geography, building type, and intended function. It is not isolated, it is not small, and it challenges the intuitive narrative that architecture primarily responds to contemporary necessity rather than speculative scenarios. As one contemplates the scale, the thought emerges: if these designs were over-prepared, what scenarios were the architects anticipating? The question is neither accusatory nor speculative. It is an observation grounded in mathematics, engineering, and documented capacity. The patterns are clear: urban planning, industrial architecture, civic buildings, and transport infrastructure collectively exhibit preparation beyond immediate need. Each building, each bridge, each plaza reflects a foresight or a philosophy of readiness that appears disproportionate to documented historical conditions. And yet, in the midst of this meticulous observation, gaps remain. Records are incomplete, economic data are patchy, and surviving blueprints offer only partial insight. The discomfort arises precisely because the scale is tangible, measurable, and undeniable, but the cause remains elusive. Step by step, one sees that these constructions invite questions about timing, population assumptions, and systemic preparation, all without any recourse to speculation about hidden agendas or conspiracies. The anomaly exists purely in the relationship between capacity and known history. If one follows the trail further, through galleries, warehouses, bridges, and civic halls, the pattern persists. The mathematical and structural evidence cannot be ignored. The discrepancy grows in significance, not diminishes. By the end of this survey, the viewer confronts a subtle yet persistent tension. These buildings, these spaces, are ready for events and populations that historical records do not confirm. The scale is there, the engineering is there, and the timing mismatch is undeniable, yet no clear explanation emerges. The discomfort is controlled, yet it compounds, building slowly, inexorably, as the facts accumulate. And in that accumulation, one realizes the narrative is incomplete. Moving beyond isolated buildings, the pattern extends across continents, suggesting an architectural philosophy that repeatedly anticipates scenarios well ahead of recorded demand. In the United States, numerous mid-19th century towns contain civic structures with capacities rivaling European capitals of the same period. Consider the multi-story exhibition halls and railway termini built in northeastern cities. Contemporary population records indicate small communities, yet the halls could accommodate tens of thousands, complete with load-bearing frameworks, wide concourses, and auxiliary service spaces. The infrastructure was ready for intense activity decades before census data would justify it. Urban planners of the era often cite future growth as a rationale, yet the precision of these designs consistently overshoots projected population trajectories. Streets are wider than necessary, public squares far larger than community gatherings require, drainage and water systems capable of sustaining volumes far beyond contemporary usage. In Boston, New York, and Philadelphia, grand civic layouts and transportation nodes suggest an understanding of crowd dynamics, vehicular movement, and urban flow that matches later industrial-age traffic, not the slower, smaller scale of mid-century realities. Each repetition strengthens the observation. These are not isolated overestimations but a recurring pattern of overpreparedness. The UK offers parallel examples. London's mid-19th century railway stations, exhibition halls, and civic centres embody similar tendencies. Massive glass and iron exhibition halls, such as those erected for international exhibitions, demonstrate capacities far beyond any documented visitor numbers. Even smaller municipal projects, like town halls and local marketplaces, show structural redundancies and spatial allocations that exceed anticipated use. The engineering specifications, arches, ironwork, and trusses, anticipate loads that the historical population and industrial activity could not generate. These repeated features invite a closer examination of design intentions and raise questions about the scale of preparation embedded in the built environment. Infrastructure demonstrates an additional layer of scale discrepancy. Consider bridges, aqueducts, and railway viaducts spanning rivers and valleys. Many of these structures were constructed decades before significant urban growth reached their regions. Yet they were dimensioned to accommodate not just current traffic but potential surges in population, commerce, and transportation. In North America, the early bridges spanning the Mississippi or connecting burgeoning eastern cities feature multiple redundant supports, exceptionally wide decks, and load capacities that exceed contemporaneous usage estimates. The mismatch between design and recorded demand is systematic, appearing across regions and building types alike. Industrial sites intensify this unease. Factories, storage facilities, and workshops in both the UK and the US show capacities exceeding their economic justification. Shipping records, workforce sizes, and trade volumes indicate modest activity, yet these buildings were constructed with structural reinforcement for far larger operations. Some warehouses feature mezzanines, high ceilings, and auxiliary loading docks designed for throughput levels well above recorded use. Even rural industries display overprepared features, such as reinforced foundations, expansive floor plans, and redundant support structures, suggesting a philosophy of readiness or anticipation rather than reaction. Educational institutions further amplify the pattern. University campuses, technical schools, and academies constructed in the early industrial period frequently contain lecture halls, libraries, and laboratories with capacities far exceeding student enrollment. In several cases, the building materials and structural planning reflect long-term adaptability, as if these institutions were anticipating future expansion on a scale not documented in enrollment records. Across continents, similar construction techniques emerge. Reinforced masonry, load-distributing arches, and wide corridors indicate systematic planning for intensity of use far beyond contemporary realities. Public infrastructure, too, aligns with this trend. Water treatment facilities, sewage systems, and public baths often show capacities that outstrip recorded demand. In London, Manchester, and New York, waterworks from the early 19th century include reservoirs, pumping stations, and distribution networks sized for populations decades ahead of census figures. Sewer networks, constructed with high-capacity tunnels, demonstrate a vision of future urban density that only later became a reality. In some U.S. cities, drainage and aqueduct systems appear disproportionately extensive relative to population data, yet they persist in the landscape as functioning monuments to anticipatory design. Transportation hubs continue this pattern. Rail stations in both continents, built to accommodate far larger crowds and freight volumes than historical records suggest, share characteristics with exhibition halls and civic buildings. Platforms extend beyond documented train lengths, concourses are wider than passenger traffic demands, and multiple auxiliary passageways exist for routing people and goods in ways that the contemporary context never required. These nodes repeat a pattern of overpreparation. The anticipation embedded in structural design transcends immediate economic and demographic constraints. Even temporary structures and ephemeral installations exhibit the same principles. World's fairs, industrial expositions, and temporary marketplaces were often built with a level of engineering sophistication that exceeded the recorded attendance. Glass and iron frameworks, reinforced flooring, and elevated mezzanines are repeated across sites, highlighting the consistency of approach across ephemeral and permanent constructions alike. The recurrence strengthens the pattern. It is not an anomaly but a design philosophy observable across geography, function, and permanence. The repetition of these patterns invites closer inspection of timing. Structures appear ready for peak usage long before the surrounding context, population, commerce, or civic demand would justify it. This anticipatory dimension extends to both urban and rural areas. Across continents, cities and towns feature monumental thoroughfares, expansive public spaces, and large-scale civic buildings, all dimensioned for activity levels not yet realized. Roads are laid out with foresight, connecting regions and public nodes with a scale and precision suggesting planning for events and densities far ahead of their time. Architectural embellishments reinforce the sense of preparedness. Domes, spires, and colonnades are integrated into structural frameworks with an understanding of force distribution, load, and durability. These features are not purely ornamental, they contribute to the building's capacity to withstand intense use. Their repetition in exhibition halls, civic centers, industrial buildings, and even rural installations demonstrates a consistent philosophy. Structure and decoration combine to create spaces ready for scenarios beyond documented demand. In the United States, the Midwest and frontier regions provide striking examples. Settlements with populations in the low thousands possess courthouses, train stations, and warehouses scaled for tens of thousands. Even accounting for aspirational growth or speculative commerce, the magnitude of overpreparation remains disproportionate. Foundations, load-bearing elements, and internal circulation systems are engineered to manage forces and volumes far beyond the documented historical context. International parallels are equally compelling. European cities, in addition to the UK, display early adoption of overprepared design principles. Civic halls in Paris, Berlin, and Vienna anticipate gatherings and events of scale unmatched by contemporary population figures. Bridges, aqueducts, and industrial complexes reflect structural redundancies and foresight aligned with large-scale urban demands that appear only decades later. The consistency across nations reinforces the observation. This is not coincidental but systematic. And as one maps these patterns side by side, railway stations with exhibition halls, warehouses with public squares, bridges with civic centers, the recurring principle is clear. infrastructure frequently precedes necessity, sometimes by decades. The readiness is encoded into architecture itself. Streets, buildings, bridges, and waterworks collectively suggest a philosophy of preparation for high-intensity usage across multiple functions simultaneously, well before historical records indicate such demand. Even as we trace this pattern, the question emerges naturally: why is over-preparation so widespread? What principles guided architects, engineers, and planners to invest in such disproportionately large and resilient structures? The record does not offer explicit explanations. Economic data, population projections, and urban growth estimates appear insufficient to justify the scale. Yet the designs persist, replicated across continents, decades, and cultural contexts, inviting observation, analysis, and careful reflection. These repeated patterns culminate in an uneasy consistency. Buildings and infrastructure across the US and UK reflect preparation for events and population intensities far exceeding documented historical need. The phenomenon is visible not only in monumental, iconic structures but also in everyday civic, industrial, and transport architecture. Each site reinforces the pattern, compounding the observer's discomfort and deepening the sense that something within architectural philosophy or planning practice remains underexplored. As one surveys the landscape of 19th-century urban and industrial architecture, the repetition becomes undeniable. Structural capacity, overbuilt foundations, expansive public spaces, and complex circulation systems all suggest readiness for scale that contemporaneous records cannot fully account for. This repeated pattern, appearing across regions and building types, hints at a broader phenomenon in architectural practice, a phenomenon that invites examination and further investigation. And as we begin to explore these patterns collectively, a question lingers. What might these repeated designs, these anticipatory structures, indicate about the underlying principles guiding their construction, and how might historians interpret the persistence of such widespread over-preparation? By now, the patterns across continents, building types, and urban scales have become unmistakable. Architectural designs consistently anticipate activity, population, and events beyond recorded need. Scholars and enthusiasts examining these structures have begun grouping these phenomena under a descriptive framework for analytical purposes. One interpretation emerging in contemporary discourse uses the term Tartaria as a label to describe the architectural and infrastructural patterns observed across Europe, North America, and parts of Asia. Importantly, in this context, Tartaria functions strictly as a conceptual reference to these recurring patterns. It is not presented as a civilization, an empire, or an erased chapter of history. It is, rather, a heuristic to facilitate discussion of scale, over-preparation, and temporal anomalies in architecture. Using this interpretive label allows researchers to examine the phenomenon without presupposing intent, motive, or historical narrative. Under the Tartaria framework, buildings, bridges, and industrial facilities that appear over-prepared relative to their immediate context can be studied collectively. The patterns are analyzed in terms of capacity versus recorded demand, structural redundancy versus known use, and urban layouts versus population growth. Observers note that, while the scale discrepancies are clear, the available historical documentation rarely explains why these structures were conceived on such a large scale. The interpretation invites consideration of multiple factors: technological optimism, speculative urban planning, and the projection of civic ambition decades ahead of actual growth. One interpretation posits that architects and engineers of the 18th and 19th centuries may have been working with principles that deliberately anticipated future growth. Population projections, industrial forecasts, and civic planning documents, though limited, suggest that some degree of forward thinking was standard in professional practice. In many cases, the over-preparation may reflect an emerging confidence in materials, engineering methods, and the reliability of structural systems. Architects may have intended these buildings to remain adaptable for decades, ready to accommodate growth, new transportation modes, or unexpected demands. Under this interpretation, Tartaria functions as a lens for examining architectural foresight rather than a hidden historical entity. Another interpretation emphasizes the role of social and cultural ambition. Monumental structures often serve symbolic as well as functional purposes. Exhibition halls, railway termini, and civic centers were designed to impress, inspire, or convey civic pride. The scale may therefore be a product of aesthetic and cultural ambition, a deliberate oversizing intended to communicate permanence, stability, and sophistication. Public squares, wide avenues, and grand domes might reflect a desire to embody progress and technological mastery, independent of immediate population pressures. Through this lens, Tartaria becomes a framework for exploring how societies expressed ambition through architecture, highlighting the disparity between symbolic intent and recorded usage. Technological and logistical factors offer another perspective. The Industrial Revolution introduced new materials, iron, steel, and glass, that allowed buildings to reach unprecedented scales with relative safety. Engineers may have explored the full potential of these materials, resulting in structures whose capacities exceeded contemporaneous needs simply because the technology permitted it. Bridges, warehouses, and factories demonstrate structural redundancy and load management far beyond documented use. Viewed through the Tartaria framework, these buildings illustrate the intersection of technological capability and speculative planning, infrastructure designed to test limits and anticipate potential scenarios. Yet another interpretation considers patterns of information transfer. Architectural plans, engineering treatises, and industrial design manuals circulated widely across continents during this period. Knowledge sharing may have encouraged replication of large-scale design principles, even in contexts where demand was modest. Structures in North America, for instance, closely mirror European examples in dimensions, style, and engineering approach. The consistent adoption of oversized frameworks could therefore reflect professional norms and educational influence rather than any historical anomaly. Tartaria, in this sense, serves as a conceptual tool for tracking the diffusion of architectural principles and evaluating scale expectations across time and geography. Historical ambiguity persists in these interpretations. Many original plans, municipal records, and industrial logs are incomplete, lost, or inconsistently preserved. This creates gaps that leave room for multiple explanations. While overpreparation is measurable and observable, the motivations behind it remain speculative. Even rigorous archival research cannot definitively resolve why so many structures were built with capacities exceeding contemporary needs. Tartaria, as an interpretive framework, enables historians and researchers to engage these questions without asserting definitive conclusions, keeping the analysis rooted in evidence and observation. One notable feature of Tartaria patterns is the repeated integration of multifunctionality. Large halls, for example, often include auxiliary rooms, mezzanines, and structural supports capable of supporting additional stories or alternate uses. Bridges and industrial buildings sometimes incorporate design features anticipating future adaptation, expansion, or higher load capacities. This multifunctionality could reflect professional practice, cultural ambition, or speculative foresight, yet its recurrence across regions remains intriguing. The pattern is not tied to a single event or locale. It is systemic, observable wherever these large-scale structures appear. This interpretive approach encourages careful, evidence-based investigation. By focusing on architectural scale, engineering choices, and urban layouts, one can examine the discrepancy between construction and recorded use without invoking hidden motives. Researchers using Tartaria as a lens emphasize measurement, comparison, and chronological analysis. Bridges, warehouses, exhibition halls, and public squares are catalogued, analyzed, and compared across continents. Patterns emerge in timing, repetition, and capacity that consistently challenge intuitive expectations. Even so, each observation remains open to multiple explanations: foresight, ambition, technology, or cultural expression. In the final assessment, Tartaria provides a vocabulary and framework for examining architectural phenomena that defy simple explanation. It allows observers to note the recurrent overpreparation, the temporal mismatches, and the technological sophistication without asserting hidden histories. By presenting the label neutrally, researchers can focus on measurable discrepancies, architectural reasoning, and historical patterns rather than drawing definitive conclusions. The interpretive framework invites discussion, debate, and exploration while maintaining analytical rigor and scholarly caution. Ultimately, the enduring unease emerges not from mystery or speculation but from the sheer consistency of these patterns. Structures across continents repeatedly anticipate usage far beyond recorded demand. The scale, engineering sophistication, and distribution of these buildings suggest a methodology in planning and construction that does not align neatly with contemporary population, commerce, or event records. Viewed through the Tartaria framework, these observations remain unresolved, systematic, measurable, yet enigmatic in origin. And as one steps back to survey the landscape of 18th and 19th century architecture, the question persists: why were so many structures built with such extensive capacity? What principles guided architects, engineers, and planners to embed readiness for scenarios that may never have occurred? Tartaria provides a neutral lens to consider these questions, to track the recurrence of overpreparation, and to reflect on the broader philosophy of design embedded in the built environment. Even without a definitive answer, the pattern demands attention, prompting continued investigation into architectural foresight, societal ambition, and the intersection of technology, culture, and urban planning. The structures remain grand, capacious, and meticulously engineered, inviting inquiry into their design, purpose, and the mindset of those who built them. Each measurement, each blueprint, each surviving edifice contributes to the narrative of anticipation and scale, leaving the observer with a subtle yet persistent unease, a recognition that something in architectural history is far more complex and layered than recorded events alone might suggest.